The shell is the primary component that contains the pressure. Pressure vessel shells are welded together to form a structure that has a common rotational axis. Most pressure vessel shells are cylindrical, spherical, or conical in shape. Horizontal drums have cylindrical shells and are fabricated in a wide range of diameters and lengths. Tall vertical towers are constructed in a wide range of shell diameters and heights. In this course, we will cover types of vessel design, design of cylindrical shell, types of dished head, optimum vessel size, tall vertical vessel, and skirt. The design of pressure vessels and vessel parts shall conform to the General Design Requirements Part UG 16, in the following paragraphs and in addition to the specific requirements. For ASME code, the code start from paragraphs UG 1 to UG 137. The minimum thickness permitted for shells and heads, after forming, and regardless of product form and material, shall be 1/16 inches. 1.5 mm, exclusive of any corrosion allowance. Types of pressure vessel. There have three types of pressure during design, such as design pressure, maximum allowable working pressure, MAWP, and operating pressure. Vessel according to end construction. According to the end construction, the pressure vessels are may be open of end or closed end. Pressure vessels according to dimensions. If the ratio T/D is less than 1/10, the vessel is said to be thin shell, and if the ratio is greater than 1/10, it is said to be a thick shell. Thin shell is for boilers, tanks, and pipes. Thick shell is for barrels and pressure cylinder. Maximum allowable working pressure, MAWP. UG 98, page 117 mentioned the requirements of MAWP. Pressure vessels must always operate at a pressure lower than their maximum allowable working pressure, MAWP. MAWP is defined as the maximum gauge pressure permissible at the top of the completed vessel in its operating condition for a designated temperature. Generally, MAWP will be higher than the design pressure because wall thicknesses are in discrete sizes and the designer will always choose a value greater than that called for. In the example, since it is unlikely that he can design for exactly 95 sig, the designer selects the next highest level, which, in this example, is 100 sig. Therefore the vessel's MAWP is 100 sig. Pressure vessels must always operate at a pressure, 95 psi, lower than their MAWP, 100 psi. The test pressure, 150 psi, for the vessel is generally 1.5 times design pressure or MAWP, 100 psi. MAWP, 100 psi, will be higher than the design pressure because wall thicknesses are in discrete sizes and the designer will choose a value greater. Burst pressure, 400 psi, will typically be in the range of 3.5 to 4 times MAWP, 100 psi. The pressure used in the calculations must be equal to or greater than the MAWP to be marked on the vessel nameplate and manufacturer's data report. A lower pressure which must be met for process conditions must not be used in the calculations. If the markings required are stamped directly on the vessel, the minimum letter size is 516 in. If they appear on a nameplate, the minimum letter size is 532 in. Pressure vessels operate with internal pressures that are either above or below atmospheric pressure. They rely on the strength of their walls and flanges to prevent failure. UG 27 thickness of shells under internal pressure. This paragraph provides formulas to determine minimum required thickness of shells under internal pressure. UG 21 states that vessels must be designed for the most severe condition of coincident pressure and temperature expected in normal operation. The code also states that the maximum pressure difference between the inside and outside or between chambers of a vessel during operation and test must be considered. Design pressure is the pressure used in the design of a vessel component together with the coinciding design temperature, metal temperature, for the purpose of determining the acceptable thickness and inherent details of the component. This should be below MAWP and based on company standards can vary from 10% to 25% above the maximum operating pressure of the system. Design temperature. UG 20 established the requirement for maximum design temperature and minimum design metal temperature, MDMT. The maximum temperature at any point shall not exceed the maximum temperature listed in the stress tables for the specification, or the external pressure chart, if the vessel is under external pressure. Design temperature for vessels under external pressure shall not exceed the maximum temperatures given on the external pressure charts. The minimum design metal temperature marked on the nameplate must correspond to the greatest value of the maximum allowable working pressure marked on the nameplate. Maximum allowable pressure, MAP. UG 98 established the requirement for maximum allowable pressure. The term MAP is often used. It refers to the maximum permissible pressure based on the weakest part in the new, uncorroded, and cold condition, and all other loadings are not taken into consideration. The MAP is defined as the maximum allowable pressure of the vessel in the new and old condition. Pressure of fluid. Pressure and depth is the fundamental relationship in the oil industry. The easiest way to calculate pressure from depth is to use the pressure gradient of the given fluid. To find the pressure per square inch for any feet head not given in the table above, multiply the feet times 0.433. 0.433 is the gradient for pure water, Sg equals 1, static gravity, in imperial units. Remember it? 13 Example 1. The pressurized tanks types can be of a spherical or bullet shape, and these storage tanks are used to store of fluids at pressures above atmospheric. The pressure, P of a water tank is 86 psi. The connecting pipe above the tank is 21 feet. Calculate the static head pressure and total pressure for the pressurized tanks. Calculate the static head pressure. 21 times 0.4333 equals 9.099 psi, from table. 0.433 times 20 feet equals 8.66. 4, 1 feet, equals 8.66 plus 0.433. Equals 9.099 psi, if no table provided. The total pressure, PT of the water tank. PT equals design plus PS. Equals 86 plus 9.099 psi. Equals 95.099 psi. Hydrostatic test. UG 99 established the requirement for hydrostatic test. Hydro test is the technique in which pipes, pressure vessels, gas cylinders, tanks are tested at required design pressure of the system or pipes or vessel to check the leak and strength. Hydrostatic test pressure is the pressure is at 1.3 times the MAWP or the design pressure to be marked on the vessel. Hydrostatic pressure equals 1.3 times maximum allowable working pressure or MAWP. Example 2. What is the minimum hydrostatic test pressure for an existing vessel that is being re-rated using the design allowable stress, where the MAWP is 1000 psi and the allowable stress factor correction is 1.0? Test pressure equals 1.3 MAWP times S test temperature slash S design temperature. Equals 1.3 times 1000 times 1.0. Equals 1300 psi.